The object is in some another medium, more implicable application of refraction of light. What is normal shift, students? Please do keep in mind there is no real change in the position of the object. So what is the maximum possible lateral shift produced? One, what we call as the normal shift, and the other one, what we call as the lateral shift. Hello students, let us continue our discussion on the chapter Geometrical Optics and Optical Instruments. What did we do at the preview or the session before this? We understood a very beautiful phenomenon called refraction of light. What was refraction? It was the phenomenon of bending of light when, as light travels from one medium to another, due to what? Change in its speed, and that is what is called refraction of light. And we concluded by studying the laws of refraction, and the most important, we studied something called Snell's law, where we told n equals sin I divided by sin R. N was a constant which we called the refractive index of a medium. It was the ratio of the velocity of light in two different mediums, and we told refractive index is a dimensionless quantity. Now, continuing today, we shall discuss the two applications of the phenomenon of refraction. One, what we call as the normal shift, and the other one, what we call as the lateral shift. So we start discussing about the phenomenon of normal shift. ಪರೀಕ್ಷೆಯಲ್ಲಿ ಇದನ್ನ 2 ಮಾರ್ಕ್ ಯಾವಾಗಲೂ ಕೇಳ್ತಾರೆ, ನಾರ್ಮಲ್ ಶಿಫ್ಟ್. What you need to understand here is the word shift refers to change in position of an object. When I talk about shift, I am referring to change in the position of an object. And here I am referring to something called as normal shift. Please do consider this example carefully. I assume there is a beaker which is filled with water. A beaker which is filled with water. And at the bottom of this beaker, I have placed a rupee coin. ಒಂದು ಬೀಕರ್ ತಗೊಂಡಿದ್ದೀನಿ. ಆ ಬೀಕರಲ್ಲಿ ವಾಟರ್ನ ಫಿಲ್ ಮಾಡಿದ್ದೀನಿ. ಬಾಟಮ್ ಆಫ್ ದಿ ಬೀಕರಲ್ಲಿ there is a rupee coin. Now what I do is, I assume or I see the coin inside the beaker. I hold the beaker like this. I observe the coin at the bottom. Things here to analyze is, my dear students, the observer, the person who is seeing the coin, I call him as the observer. The observer is in the rarer medium. And which is the object? Object is the coin which is in the denser medium. Andre, the observer is in some different medium. The object is in some another medium. And most importantly, I am observing the coin along the normal. The observer who is in the rarer medium is looking at the coin normally, exactly somewhere like this, and it appears to be along the normal. Now what happens is, for the observer in the rarer medium, the coin appears to be here. There is a shift in the position of the coin. For the observer, the coin appears to be somewhere here. It feels that the position has shifted. But has it really happened? Illa. Coin is still at the bottom of the beaker. The observer feels that the position of the coin has shifted. He feels that, and therefore I call this shift as the apparent shift. Apparent andre something which is not true. The coin is at the bottom, but for the observer, he feels that the position has shifted. Apparent shift. And that is what is called normal shift. So what is normal shift by definition, students? It is the apparent shift, not the true shift. The apparent shift in the position of an object which is placed in one medium. The object is placed in one medium and seen normally through the other medium. The object is placed in one medium and it is seen normally from the other medium, there is an apparent shift now, and that apparent shift is called as normal shift. So what is normal shift, students? Please do keep in mind there is no real change in the position of the object. It is only an apparent change. It is only an apparent shift in the position of an object which is placed in one medium and observed normally through the other medium. Very clearly, coin is placed in the denser medium, viewed normally from the rarer medium. The position of the coin appears to be shifted, and that is what is called normal shift. Now, normal shift is given by the expression NS equals T 1 minus 1 by N. The expression for normal shift NS equals T 1 minus 1 by N. What is T? It is the distance of the object from the bottom to the surface of the medium. Whatever shift has happened, whatever apparent shift has taken place, that is represented as T. And N is N12, the refractive index of the two mediums. It is called relative refractive index. So, the expression for normal shift NS equals T 1 minus 1 by N, where T is that apparent shift, N relative refractive index of the two medium. Now, what are the factors on which normal shift depends upon? It depends upon the shift T, distance of the object from the bottom to the surface, refractive index of the medium in which the object is placed, refractive index of the surrounding medium, thickness, refractive index of the medium in which the object is placed, refractive index of the surrounding medium. Now, the same way, we try to understand what is lateral shift, the more implicable application of refraction of light, something called lateral shift. And the word lateral means perpendicular. Again, I consider a parallel-sided glass slab. It has parallel sides, which is placed in the air medium. The glass slab is surrounded by air. So air is the rarer medium. Glass slab is the denser medium. AB is the interface. As I told, it is a surface which separates the rarer medium and the denser medium, and MN is the normal. Now follow carefully. A ray of light PQ is incident on the surface AB. PQ is falling on the surface AB, where we believed it has to pass straight without any deviation. But since it travels from rarer to denser medium, optical density changes, the speed of light changes. So there is bending of light, which is called refraction. So light is bent along QR, which is now incident on the surface DC. After refraction, the ray QR, after being refracted, it is falling or it is incident on the surface DC. Now at the surface, the ray RS is coming out, and therefore RS is called the emergent ray. It is emerging out of the glass slab, emergent ray. Observe, my dear students, if you clearly observe, there is a perpendicular distance between the incident ray and the emergent ray. Perpendicular distance between the incident ray and the emergent ray. I am talking about RT, and this RT is what we call lateral shift. So by definition of lateral shift, it is the perpendicular distance. I told it very earlier. Lateral andre perpendicular anta artha. Perpendicular distance between the emergent ray and the direction of the incident ray. That perpendicular distance between the incident ray and the emergent ray, when light passes through a glass slab, is called lateral shift. And what is the expression for lateral shift? T sine I minus R divided by cos R. Again, a classical example or expression. Lateral shift is T sine I minus R divided by cos R, where T is the thickness of the glass slab, I angle of incidence, R angle of refraction. So lateral shift is T sine I minus R divided by cos R. Now, lateral shift produced by a glass slab is minimum when I is equal to 0. When the angle of incidence is 0, there is no refraction at all, no emergence at all. So lateral shift is also 0. And maximum when I is 90 degrees. So lateral shift is T sine I minus R. I is 90 minus R divided by cos R. Sine 90 minus R is cos R. So it gets cancelled. What remains is T. So what is the maximum possible lateral shift produced? It is nothing but the thickness of the glass slab. So students, we very clearly saw today what was normal shift and lateral shift. Apparent shift, when viewed normally from one medium where the object is placed in another medium, is normal shift. Perpendicular distance between the incident ray and the normal emergent ray is lateral shift. Again, in my next session, I turn up with one more beautiful application called total internal reflection. Until then, have a nice time. Thank you.